Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering.
On this episode, we talk all about privacy. We're joined by Abhishek Bhowmick, the co-founder and CTO of Samooha, a startup that lets companies collaborate and share data in a secure way. And we're also joined by Ian Coe, the co-founder and CEO of Tonic, a startup which helps developers and data scientists get access to realistic data without compromising privacy. This is a fun episode because often privacy and governance can be seen as limiting, but we instead look at some examples of how companies can reduce red tape and increase access to data safely so their employees can do their best work. And we go deep on synthetic data, some of the math behind ensuring differential privacy, and how companies should think about privacy in a world where generative AI is well adopted.
So we talked about this in the early parts of this conversation, but this was a learning experience for me. The topics we got into, I wasn't totally unfamiliar with, but I definitely feel like this is not my area of expertise. Do you feel like you learned a lot in this episode too?
Yeah, I learned a ton, especially just some of the technology behind what does privacy really mean from a technical perspective was interesting because it does have mathematical implications to ensure that something is private. I thought it was super interesting because Abhishek and Ian both come from big companies that were leading the frontiers of privacy, Apple, and also Palantir, which are notoriously known for needing to have very high standards on privacy because they deal with such sensitive data. And I think they're bringing a lot of those deep backgrounds to smaller companies or making it more accessible.
The sense I got, and we'll be interested to hear from folks after this drops, is that this is an area where we are figuring out the techniques and best practices, but I don't know that we have yet boiled everything down to a way that all analytics infrastructure should be architected now that we know how to do synthetic data really well, or now that we know how to do different. I feel like they still require deep engagement with the thought that they like tools themselves, and then you have to figure out on a one-on-one basis, how do you apply this to my particular context?
Yeah, it's definitely not table stakes yet. Certainly feels frontier-ish. But we'll get there. And before we jump into this episode, I want to mention this is the last one of the season. We crossed 100,000 listens and we're grateful for your engagement. Woohoo! We'll be recording the next season in a couple months. So if you have suggestions for guests, please find us on Twitter or by email. We want to hear from you. And so without further ado, let's get into it.
Ian, Abhishek, welcome to the Analytics Engineering Podcast. It's great to have you both. This may be the single episode where I feel the most out of my depth ever. I've done reading in the past about various ways that you can come at data privacy, but I have every expectation that this is going to be an episode where I, and maybe Julia, you too, end up doing quite a lot of learning from the two of you. Before we get into that, I'd love it if you could both take a minute to introduce yourselves.
Hey, great to be here. My name is Ian Coe. I'm a CEO and founder of Tonic. Basically, just to give you a little bit of background, I've been in the data space for about 15 years, spent a good amount of time at Palantir and at Tableau. Before that, worked at a hedge fund where I also dealt with a lot of data. So I assume we'll get into it, but have a lot of thoughts on privacy and, how it relates to being able to move data around and everything.
Abhishek, how are you?
Thanks, Tristan. Great to be here. By way of introduction, I'm Abhishek Bhowmick, co-founder and CTO at Samooha, the cross-cloud secure data collaboration platform for enterprises. Before Samooha, I led privacy-preserving machine learning at Apple for over 5 years, shipping a bunch of privacy-enhancing tech at a scale of billion-plus iPhones. Prior to that, I spent some time at Goldman Sachs running returns optimization on their trillion-dollar balance sheet. But before industry, I spent some time in academia, and interesting background, one of my most notable works there was solving a 30-year unsolved math problem, for which I had the opportunity to be one of the youngest invited speakers at the Institute for Advanced Study in Princeton, which is home to Einstein and von Neumann, as you know. So it's been quite the arc from foundational whiteboard math to shaping products at scale and making a difference.
That may be the first time any intro has ever included solving math problems. That's very cool.
Thank you.
My younger self was a a very big math geek. And when I visited Princeton, I tried to sit in on like Andrew Weil's classes so I could learn from like the most famous ever unsolved math problem that was solved. But this is an area that, Tristan, you're not alone. I too am a bit of a novice here. So we're going to learn a lot on this episode. I think privacy is a conversation that lots of people are having at the enterprise. Smaller companies are having it too, but it's usually seen as this like governance thing or a thing you have to do at a company for compliance. But what I really like about our two guests today is that they're thinking about it as how can we remove red tape from businesses and enable them to do the work that they want to do in a secure and safe way. And Tonic and Samooha take very different approaches to that problem. Tonic helps developers get access to more data and using synthetic data, so it's private and secure. And Samooha also helps enable businesses work together and collaborate with data in a private and secure way. So it's not thinking about it as this like negative thing, but really an enabler for your business and removing red tape. But maybe to start off, why don't we have a conversation around privacy? Like who's thinking about it today? Who's pushing the conversation forward? Do all companies make this their top level priority, or really who does it concern today?
I really like what you said there around seeing some of the trade-offs. I mean, that's actually sort of what Tonic was founded on, is sort of this idea that we basically like in our prior, in like all the founders' prior jobs, what we kept feeling was data could either be secure and not that useful, or insecure and, really powerful for the whole enterprise. And, we had a ton of experiences like that. I would be on site at a big bank, not be able to debug something that I was trying to implement because developers back in Palo Alto couldn't see data. So this was definitely, kind of a top priority for us as we were thinking, sort of brainstorming ideas. I think today, in terms of like why people care about privacy, we kind of see it as both privacy and data risk to a large degree. And that kind of broadens the conversation a little bit. And so obviously you have, sort of classic like regulatory pressures, GDPR, HIPAA, PCI, what have you. But you also have, data breach risk, which is coming up more and more, especially as people are using data for more and more, for generative AI, for developing software, data-driven products. As people need to start aggregating data into places where it can be accessed by many, many people, it just gets more and more complicated and it gets harder and harder to protect privacy. You can kind of, the classic personas that you would think of are, often the first ones to kind of sound the alarm, CISOs, compliance folks. But we're seeing more and more DevOps, data infrastructure, seeing this as like a first class responsibility for themselves.
And I couldn't agree more. Privacy is increasingly becoming more and more mainstream, as you can see. And privacy is about empowering these end users with more control over their data, more transparency. How is the data being protected, secured, while at the same time driving customer value? The two main threads in which these conversations are pushed are, one, privacy by product and by design from the get-go. And second is privacy by regulatory compliance, as Ian also alluded to. But they're both geared towards a common goal, right? More privacy, more security, and more governance around PII data. Product-oriented offerings that I talked about are mostly championed by consumer companies like Apple, and also enterprise clouds like Snowflake, AWS, GCP, Azure. They all have their own privacy-enhancing frameworks that are rolled out for companies to build privacy into products. And compliance-driven privacy, on the other hand, is mostly led by regulatory agencies in sovereigns, both in EU and the US. We'll talk about some of that in more detail, and leading to regulations like GDPR, CPRA. Our observation has been that the privacy-enhancing frameworks that are being thrown out there, they're still not been made super easy to incorporate and build into products. Practically speaking, it might appear to be a luxury that only big tech companies can afford. So our vision at Samooha is to be that big, easy button to bring these technologies into life, into end user facing products at these enterprises.
Just to add to that a little bit, we totally see it really does matter kind of what your industry is, but so it matters and it doesn't, I guess is what I would say is what we'd see. In the long term, for most businesses that reach scale, we see them having to take this on. What we've kind of seen as we've been in market is that depending on your vertical, you will adopt at different moments. So, if you're a healthcare company, you might adopt a product like Tonic at 10 people because HIPAA is so onerous that it really just kind of change. It really drives, sort of your whole data culture from day one. A financial services company, maybe 50 people. If you're just kind of like an average B2B company, like 200 people. So, that's when, you hire a CISO, potentially. That's when you maybe do a SOC 2, maybe you sign a contract data covenant in it with a big customer. Then, B2C, more like 1,000. Obviously, these are broad strokes, but definitely agree with what Abhishek's saying that, depending on, B2C, B2B, all these things kind of drive, what your data culture and your sort of privacy and data risk tolerance is.
The stage thing is interesting. DBT Labs as a company benefited versus certain earlier open source innovators by the fact that we were first created in an environment where Kubernetes already existed. And so when you kind of construct your architecture in such a way that anticipates containers and Kubernetes, you can kind of like skip a lot of like annoying stuff that other companies that were founded before that had to deal with. I'd be curious, do you think that with the set of new technologies that, Abhishek, you were talking about, making privacy easier, which makes me think it's not just easier for large companies, maybe it's easy enough for small companies to deploy many privacy technologies as well. Do you think that if there will be huge advantages to companies just kind of baking this in from the ground up, it's probably far easier to do that than kind of reverse engineer a complex product and business processes?
I 100% agree. The level of mainstreamness privacy has achieved by this time, it is extremely important that companies have this right from the get-go. That's where the privacy by design comes in. Because imagine the amount of effort a company would have to go through at a later stage if they have to re-architect things. And it's just extremely cumbersome, extremely expensive, resource intensive. Like if you think about when GDPR came in, a lot of even medium, forget the big tech players, but even medium tech companies, at least a year to just re-architect and get compliant, where the basics were pretty straightforward, like right to delete, have full visibility, catalog the data about each of your users. They were very basic things that these regulations expect. So having this from the get-go is very, very beneficial and in fact, the right thing to do.
So I want to talk a little bit about synthetic data, which was a newer term for me a few years back. You mentioned, Ian, specifically that like healthcare companies or financial services companies, they're usually on the forefront of privacy. But I actually learned about synthetic data from an unusual use case, which was driverless cars or autonomous vehicles, where they were creating vast amounts of synthetic data to create simulations so that they could teach the cars to drive in these environments where you needed lots and lots of data to be able to go on the streets. So synthetic data, in a sense, it's fake data that replicates real life data. In this case, it was like geospatial data. But there's all these other use cases at companies where synthetic data is perhaps really valuable and enabling. One of the cool things that I have been seeing a trend on is developers and data scientists too getting to work with synthetic data instead of production data, which is what Tonic helps support. What is like the use case that you see that's most exciting that people can accomplish using synthetic data versus real data?
I think you bring up a really good point. There's a ton of applications out there, and certainly regulated industries feel a lot of pressure to do this, but we have hundreds of customers at this point, and many of them, fall into that sort of like, B2B or B2C category where they are not, financial services and healthcare. When we started, we actually assumed, that's going to be where we grow. And, a lot of our seed stage conversations were about that, but it actually hasn't been. It, like I said, sort of depending on sort of the maturity of businesses, really, when that interest peaks. In terms of self-driving cars, obviously that's kind of an images use case. That's an example of synthetic data. We actually focus more on relational data. So, the use case that we're really excited about and what we, almost all of our customers are doing is getting data to developers or data scientists so that they can do their work and leverage all the power of production data without actually having to bring in all the sensitive data to a lower environment where they can be productive. Give you an example. So eBay is, a customer. They've been a customer for a long time, really great partner. They use us to create staging data, and that reflects the real complexities of their, sort of highly intricate and really intertwined systems. They're they're a really talented engineering team. And so they've built out a lot. But basically, they have a lot of ontological complexity where, the relationships within the data have grown, as eBay's application have grown. And so, they've been building for 2 decades, and, that has really created a complex data system that's enmeshed in a lot of intricate ways. So to actually synthesize that, requires, a pretty flexible platform. And so, the data, basically is like, it's across multiple databases, obviously lots and lots of tables. And so what we do is we create realistic staging environments that, are all of different sizes and, for different use cases. And all of that, is automated and updating. And that's really where sort of power of a DevOps focused synthetic data platform comes in that it's, very scalable. It's easy to update, and we can, protect the data and report on all of that. So there we're actually serving about 4,000 developers. We can, make, we take 8 petabytes of data, we downsample it to be, useful. Some things can fit in laptops, some things can't. Basic. This point, as I understand it, 90% of their automated testing happens on Tonic generated data. And it has resulted in an increase in integrations tests passing by more than 50%. So, it's been a huge savings for them, really awesome achievement on sort of the privacy and data security side. But, it's been kind of that, nice win-win that we really like to see, where it's both a productivity boost and really helping on that security and privacy posture as well.
My guess is you run into this all the time, but I had to, in a prior company, I worked at a company that made an analytics product, and we had a demo environment that we wanted to give our customers access to. And it turned out to be tremendously complicated to create a realistic fake data set, even on 3 tables. Because even if you're trying to mimic an e-commerce company, it turns out that the number of relationships in the data, just in like an orders table, if you're going to kind of explore through that data, you want it to look and feel real. And if there's no seasonality there, then you're just going to be like, this is stupid. This is not real. We tried a number of different ways to try to generate realistic, and we did okay, but it was an extremely simplistic use case. And even then it was challenging. So what I think you're describing is that probably developers at eBay had different approaches to generating fake but pseudo-realistic data that none of them was fully sufficient. And so at the end of the day, probably in order to feel more confident, they had to create staging environments or local environments or whatever that was on some level using production data, which is inherently not a good idea. Or they had to make some kind of trade-offs because they couldn't mimic the data effectively enough. Is that correct?
You're highlighting something that's, we really run into when we talk to folks, and basically talk to folks like yourself who've tried to do it and recognize that, wow, this is brutal. And then we sometimes occasionally talk to folks who haven't tried to do it and think, oh, this shouldn't be too bad. And then,
right.
We always try to warn them, and we try to say, hey, we'll be here when.
Right. You talk to them again in 3 months.
Yeah. When it goes sideways. But yeah, I mean, it's tremendously difficult, right? I mean, most real application databases have, not 3 tables, but like 3,000, right? Or, somewhere in between there. So it's something that we spent a lot of time thinking about, how we replicate foreign key relationships, how we can preserve some of the statistical properties like you're talking about. And depending on what you're trying to do, the graph of the data or sort of the statistical properties can be more important. On the data science side, obviously, it's more statistical properties. On the dev side, typically it's more kind of the graph of the data itself. But, both matter. Both are something that we spent a lot of time on. And as you're saying, yeah, most companies have done something at this point, especially, at the size. And so the productivity boost we typically see is replacing a lot of that data that, as you're saying, like might be, of mediocre quality, or, there's a, bunch of kludgy scripts that, generate it and they fail and you have to go back and there's a ton of maintenance. So that's where we see really big productivity boost is, when someone has gone out there and done something, then we can, come in and help them make it better, help them spend a lot less time and focus on, what's really important to their business.
Where my mind goes is, if you can have data that represents statistically accurate what the real data looks like, perhaps you could even run experiments on it. We had the Stitch Fix folk on a really early episode of this podcast, and they talked about how expensive some experiments could be to run because you need to have them open and live for a period of a year to get enough information from your users to have a relevant result. But I imagine if you could create volumes of synthetic data that was pretty accurate to the body of data that you wanted to test, perhaps you could enable a new use case as well. So that's pretty interesting. How are you able to preserve that utility while ensuring that it's anonymous? And are you keeping some of the real user data in the synthetic data, but removing the ability to identify people? Curious how the synthetic data is created.
What you mentioned is really accurate in terms of, we are, especially, so we have two products. One is really focused on developers. One is focused on data scientists. And for the data science product, there's obviously, privacy applications. But as you're saying, there's also applications that we're seeing that folks are using it for to rebalance data and, sort of remove certain biases from data. And there are cases where you can even, with rare events and things, synthesize more data and build a better model. A lot of this is use case specific, but yes, you're 100% right. Synthetic data can help in some of those cases. In terms of the sort of privacy utility trade-off, it's hard, right? Like generally there is a tension there, right? Like, the most useful data is production. The pragmatic thing that we do is we provide a lot of reporting to our customers so they can see it. It shows comparisons of the original data to new data, a lot of different slices there, especially important for data scientists who are really going to be looking at that. Developers, the developers have a slightly different bar, I guess you could say. Typically it's like, hey, the application runs, my tests run. Okay, I'm good. It's a little less important in a lot of cases to do sort of these statistical comparisons. On the theoretical side, so we never, as a practice, push production data to a staging environment. Certainly, you can use our product and do anything you want. You could do that, but that would never be something that there's nothing that we do that explicitly does that by design. If we're going to push noise data or something like that, typically what we'd be looking at is something more like differential privacy, which provides mathematical guarantees around the privacy of data. So that's actually sort of how we think that's one of the ways we measure privacy of the data is looking at epsilon values, things like that. So there are things you can do. It is complicated. The attack vectors, obviously, on data are sort of endless. So it's never easy to say, oh, this data is like this % secure, or something like that. But there are, as a differential privacy, in our opinion, is sort of one of the better ones in terms of trying to get you to that kind of conclusion.
Abhishek, I was wondering if we could get you in the conversation because I know you led all of ML privacy and cryptography at Apple, and they were very much leaders in differential privacy. First, what is differential privacy? Can you define that for our audience?
Sure. It's a perfect segue. So differential privacy, or DP, is a mathematical form of privacy that protects row-level user data while still enabling analysts to learn statistics, analytics, run ML on the population as a whole. And this is done by adding carefully calibrated noise at various stages of the analysis. So I'm going to give you a simple example. Say I want to do a survey and I want to know what fraction of the users are Democrats. And I picked a sensitive question because that is something my participants in the survey are not going to be comfortable sharing that with me. In a non-private world, what would happen is everyone will share their response in the clear, saying 1 for yes and 0 for not a Democrat. I collect all the responses, take the average, I'm done. But in the privacy world that we live in, this is where differential privacy will help. And here's how it will work. Every participant on a piece of paper writes if they are, let's say, Democrat leaning, so 1, else 0. Then they pick a random number between -10 and +10 and add that to their true signal. So let's say I'm a 1 and my random number I pick is +5. I add +5 to 1, I generate a response 6. 6 is what I send back to the owner of the survey. From a privacy perspective, you can see how the participant is happy because all they sent was a number 6. As an owner of a survey, I cannot tell if that person is really which way they're leaning, right? From the utility perspective, it is not that much of a problem because the moment I add up everyone's responses across the population, by law of large numbers, the additive noise, which was equally balanced between -10 and 10, will eventually cancel out. And then the true response surfaces. And that's precisely what I need. I need an overall percentage. I don't need to know individually who is leaning towards what. So that's at a foundational level, a very simple explanation of the underpinnings of differential privacy. I'm happy to talk about more details on some use cases that we did back at Apple as well, and also how we're using it in Samooha. But I hope this clarifies.
How large of a group do you need in order to be able to use techniques like this? How large are we talking about?
The way the error scales, your question is spot on. The final percentage that I get will have some error, right? And when will that error be very, very trivial and not hurt my utility? So a mathematical way to look at that is the error is effectively 1 over square root of n, where n is the number of people in that population. So if I'm looking at a 10,000 population study, then 1 over square root of 10,000 is basically 1 over 100. So that's 1%. And what I'm guaranteed as a result is that if the true number is 43%, I'm going to get 43 plus or minus 1. Now take it to the next level, 10 million, 100 million. You can see how the error just vanishes to the point that at that point it's trivial. That's how the error decays as the population size grows. 1 over square root n, the magic number.
I really like the example you gave there. I've heard a less PC version of that example where I think it was actually what some psychologists did in the 70s. They wanted to find out how many college students were cheating. And they asked, everyone, are you cheating? And then they said, flip a coin to see if you put for the 1 or the 0. But I really, really like that example. I think it's really cool.
Thank you.
Interesting. So professors were able to figure out how many people in their class were cheating, but they weren't able to identify who.
Who exactly?
Yeah.
They'll get a rough sense. By the way, as you might know, US Census also adopted DP, the latest one, and it's becoming very mainstream, even with regulators. A lot of companies are adopting DP because they also want to be on the good side with regulators. They'll say, well, we have differential privacy in our toolbox. We have seen that a lot.
I was wondering if you could share some more examples from your time at Apple, because they're dealing with billion, I think it's with a B,
yes,
consumers of their products with, everything from the App Store to they have a browser, Safari, they have password managers. How are they dealing with consumer privacy? Like, they have to be obviously at the forefront here and good custodians of user data. Any interesting work that you can share from your time at Apple?
Maybe the most basic version of this is like, if you're Apple, what user attributes do you apply this type of thinking to, and where do you not? Because my assumption is you wouldn't apply this to every piece of data that might flow to the company.
Yeah, let me touch on that. The good news is a lot of the work that I did while at Apple, we want to be very transparent with our users. So all of that is available on Apple's privacy website as well. So I'm going to share 3 examples from there, and we'll keep it very use case driven, as Tristan, you also highlighted. The first one is, as you can see with technologies like differential privacy, one can learn behavioral trends at the population level without needing to know what each user or iPhone behaves like. For example, this is used in usage patterns in the health app that you use, what data types you engage with in the health app, what new words are typed on the keyboard, popular new words that are being used, which are not in the lexicon, what websites are being visited on browsers with certain characteristics. And then these overall statistics and histograms of these, whether it's popular health data types being used, websites, would then feed into future feature decisioning and investments in the company. The second example I wanted to share with you was training better language models without needing to move any data from people's personal devices into the cloud. So here you can train keyboard language models by fine-tuning these models locally on their iPhones using techniques like federated learning. And thereby, what you can do is you can personalize the language model to the style that the user interacts with on the keyboard, while at the same time maintaining the guarantee that their private and confidential data does not go to the cloud.
So does that mean like you train the model locally on people's user data and you send back information like the weights used, but nothing about the individual's usage behavior?
Yeah, just to double click on that, the fine-tuned models, the way federated learning works is you start with a global model, and that model is shipped to devices. Then these are fine-tuned on local devices, right, on their data. And only differentially private gradient updates are then sent back to the server. And what the server does is it's thinking that each device is sending me a direction I want the gradient to go in. And it's going to take an average of all those gradients and say, let me update my main model in one macro step in that direction, and then ship that the next day. So that's how federated learning works. And as you rightly pointed out, it doesn't require any user data leaving the device ever. It's differentially privatized gradients that leave the phone. I did want to close with one more use case, which I think you will find very interesting, which was pretty much the most recent work before I left. This was in the context of COVID-19, where we shipped a private analytics platform that was in partnership with Google. And this was basically the largest secure multi-party computing deployment, if you think it's iPhones and Android. So that is not surprising at all. And this was used primarily by health authorities at various US states and also EU nation states to understand population level dynamic statistics in an effort to safely navigate the pandemic. So these are some of the 3 use cases which I hope highlight how privacy can be brought.
I remember like a funny situation last year when I got COVID. I reported it, and within hours, my iPhone sends me a message that says, warning, there's a detected nearby case of COVID in your proximity. And I'm like, yeah, it's me. But I think that like may have been using like differential privacy where they knew someone had COVID in the proximity, but they didn't know specifically it was me. But that is a really like exciting use case that was used to help people during the pandemic.
I think it will not be controversial at all to say that, at least as end users, we feel relative security because of these kinds of user-friendly, privacy-friendly practices that Apple natively builds into its products. And this is also very inspiring for me and part of the reason to start Samooha, because we want to deliver this at scale for every enterprise, not just at Apple.
So I give myself a rule to not bring up too much about generative AI in the first half of the episode, because otherwise the conversation just will get too derailed. But I do think there's like an interesting conversation to be had about privacy and generative AI. Should we be paying more attention to it now? Should we be concerned about generative AI having user data? Should they have synthetic data? What is the latest perspective from 2 privacy experts on generative AI and privacy?
Well, first, I feel like we should have had a contest to see who could do the most hilarious image with Stable Diffusion or something, but maybe we can do that
it's
after.
a podcast.
Yeah. Well, we could submit them
Audio
on our website.
only, yeah.
Yeah, it's true. Obviously, the promise of generative AI is, large. It would be a very, very significant understatement. But it also does present some really significant risks. And, we think that there are, some really big risk vectors that enterprises are going to have to start thinking about. I think one of the things that's interesting is that data is going to be very, very important to make progress on sort of future models. So obviously a lot of them, everyone's excited because the models have gotten really, really good, really, really fast. Some of that is, increased parameter size. Luckily, some of that is increased data. Kind of where we're at right now is that most likely future advances are going to really come from data, and that parameters themselves, just adding more and more, are going to start having really big diminishing marginal returns. This means that your machine learning teams, when they are trying to compete with other companies or just trying to make progress, are going to come to the key holders of data and say, we need it. And we happy to get into more details. We actually have a webinar on all of some of the theory behind all of this that you can find on our YouTube channel. But basically, so the 3 risk, sort of 3 big vectors for risk that we see are one, you're going to have to, if you're not doing a federated approach, which is, there's a lot of complexity there. Obviously Apple's talented, can do it, but like that's going to be a big lift for a lot of companies. So, a lot of companies are going to be aggregating all that data for training in a central place, typically in an environment that doesn't have the same security that a production environment would. So that's kind of the classic moving data to low environments problem that, we saw with, developers and, saw a big opportunity there to help reduce the risk of breaches. But we expect that there to be some increased risk of breach as folks try to get this data all together. Another thing that we expect to start happening, and we're already seeing some examples of this, as the model gets more complicated, they get better at memorizing data, meaning that there's risk that your training data gets actually revealed by the model. And in a second, I'll talk about how this has already caused some lawsuits.
Don't tell your secrets to generative AI because it will remember.
Yeah, right. That can
company data is, your competitive intelligence.
Yep. So that's certainly a risk. So there's literally revealing, PII from the training data. You put PII into the training data that can get revealed. And then also just, what happens when the model itself learns aspects of your business that you may want to keep confidential that are a little bit more subtle than just revealing PII. And then the last thing that I think is going to be really hard, and I think actually we're seeing a lot of folks wrestling with this today, is, to take advantage of this today often requires sending data to a third party. And OpenAI has been, moving their privacy policy, I think, generally in a good way. But obviously, there was a period where OpenAI was training on the data it was getting. And so this presents challenges to folks. As folks are sending to more and more third-party models, how do CISOs, how do compliance folks think about, hey, I have a data analytics team that's going to be 10 times more productive if they can leverage these models, but they may need to send data to a third party. But yeah, just to sort of bring this home and, make it really concrete. There's lawsuits happening today on this. So GitHub is being sued for Copilot. Part central to the lawsuit is that Copilot, when properly prompted, actually does reveal portions of copyrighted code. So the idea of memorizing data it's not just theoretical, like it's a real thing. Stability AI is being sued by Getty Images for using copyrighted images in training, and part of that is that part of the reason they're in a weird spot is that some of these images actually come out with Getty watermarks. So again, you can get some pretty weird spots when the models get really intelligent and start memorizing aspects of the training data. And this is stuff that's been trained on quote unquote public domain. So it's only going to get more wonky as we see teams start throwing in really proprietary data sets and, how they prevent some of these, big risk vectors from becoming problems for companies.
Yeah, I 100% agree there. Like, as we know, we are living in a moment of reckoning where generative AI is literally pushing the boundaries of what humanity can achieve. But as Ian rightly pointed out, it is coming by being arguably indiscriminate about how data is being used for their training purposes. And more precisely, enterprises will have to upload this data into training platforms like OpenAI for this to be trained. I don't think that is a steady state for us to be in. And even at Samooha, we're building towards a world where even power of generative AI can be delivered in a zero trust, privacy friendly way and enterprise friendly way. And by that, I mean training it at the enterprise tenant itself, similar to how you saw the training of language models at edge at scale at Apple. But here, of course, we're talking about enterprise tenants. We're not talking about a billion phones. But yeah, that is what I feel is where the steady state would be headed, which will strike the right balance between privacy and the massive utility boost the world is going to see.
Yeah, it's super interesting because Abhishek, that's pretty much what Samooha does a little differently, but it's how do you share and collaborate with data with a third party in a private and secure way? And usually it's, between two businesses that need to transact or figure out a workflow where they have to share data in order to enable their businesses. But generative AI is really just a third party. And is there a way to do it in a safe and secure way that your company can feel confident that you're not exposing them to real risk?
Yeah, and that has been our founding principle ever since Kamakshi, my co-founder Kamakshi and I started this. It was rooted in the belief that we are going to bring compute to where the data sits, as opposed to upload data to a compute platform. And whether it's doing search, analytics, or even enterprise data sharing, we're able to bring a lot of these, even deep learning libraries, at the source of the data, whereby enterprises are able to actually run AI/ML workloads on joint data sets across clouds, across companies. And we have a bunch of these live in action in the wild with several Fortune 500 companies.
So bring the model or compute to the data versus the reverse, which is letting the data leave the organization.
That's correct. Yeah.
Yeah. On the third party thing, I think also we are going to see increasing opportunities to run your own models. I haven't caught up on the latest on like what Azure is offering, but I expect if they haven't already, you're going to be able to start, running your own, fine tuning it in your VPC. I totally agree. We kind of get into it a little bit in the webinar and so when we talk about some of the solutions on sort of like generative AI and data risk. But yeah, exactly. Like you can mitigate some of the risks by having it stay within your network. I think that's obviously always better. It kind of reduces third party risk. That may be too hard for some companies, but you definitely still also think about sort of the model memorization issues, which is where I think stuff like differential privacy comes.
Can we go back from very sophisticated, fancy use cases to like really super basic conclusions from this conversation? On this podcast, we will have used the term modern data stack in basically every episode that we've ever recorded. And you could roughly define the modern data stack as ingestion, transformation, visualization, and a cloud data platform underlying all of that. And if you look at many of the cloud data platforms, they're implementing some functionality that is privacy focused. But the conversations that we've had here, I get the sense are maybe a little further afield than like dynamic row masking, which like is useful. Like I want dynamic row masking and that's an incredibly useful construct. But my understanding is that maybe one or maybe both of you has a different perspective on like how will privacy and the trends in privacy impact the modern data stack and the work of practitioners in the modern data stack today.
As you rightly observed, the modern data stack is evolving with the advent of more and more privacy becoming mainstream. Think of what Samooha is doing. We have basically built a zero trust encryption layer around whether it's data warehouses or infra clouds, wherever the data sits. And as a result, these participants of a clean room, which is one incarnation of a secure data collaboration platform, is able to run business use cases like you said, something as simple as I just need to know common customers I have with you, so I can maybe do joint marketing opportunities. Even on the clinical side, hospitals want to know how many patients they have in common, so they can do joint clinical studies and things like that. And a lot of this automatically comes through these pre-baked templates that we have, which are obviously sitting on the foundation of row redaction, thresholding, and masking. But then they also have these additional layers of differential privacy, end-to-end encryption. And the key here is to productize this and make it a one-click solution or no-code interface. Like people understand these things exist, but it's very hard to use it.
I get where you're coming from, but maybe the thing that feels so different to me is that when we were talking about differential privacy before in the use cases with Apple, it's not like the raw data gets uploaded to some Snowflake database somewhere, and then privacy techniques are layered on in the context of that data warehouse. Much of this is happening at the device level, and the company never gets to know. So I think that some parts of what we're talking about here can be applied by data practitioners inside the context of a data platform, but also some of this has to be applied upstream. Is that correct?
Yeah, there has to be a upstream angle as well. But just to translate it into the context of enterprises, any enterprise who already has a ton of data sets in their cloud warehouse, let's say Snowflake, they will be able to download Samooha, the app, the native app, which has the necessary transformation logic, which they can avail of saying, I want to share with this participant. I want to share with these users in that participant. And these are the kind of row redactions I want to put in place on my data. And then when they invite the other participant who may be a Snowflake customer, who may be an AWS customer, they're able to run these analysis either via developer mode interface or a UI interface and run analysis. So the way we bring this to market and the way I feel is the most advantageous way to roll this out is the apps that we develop are installed at the enterprise source, meaning they're sitting right next to where the data is. So all of the transformations can be applied by the owners of the data without having to worry about, am I uploading this to some third party like Samooha. And that is something that has resonated a lot with the Fortune 500 companies we talk to, because their basic stance is, we don't want a third party to be in the mix. I want to share something with a Coke or a Pepsi. Can we just have a contract directly without a middleman coming into the picture? And that's where this kind of an interface works beautifully.
So it sounds like privacy is complicated. It's a combination of simple things like data masking, data tokenization, differential, but then there's more sophisticated things downstream like differential privacy, synthetic data that all comes into place as well. We're going to wrap up and we're really out of time. So we're going to ask for just a couple words. Looking 10 years out, what do you hope will be true for the data industry? Ian, why don't we start with you?
My hope is that, sort of as I mentioned with sort of like the founding vision of Tonic, is that the trade-off that people feel around, sort of data privacy, data security, and utility continues to decrease, and that, the pain that that folks feel really goes down. And that, I think what we'd like to see is that, people can avail themselves of the tools to, minimize, sort of data risk, data proliferation. We didn't really even touch on data minimization, but that's a whole nother thing. But what we're already seeing within our customers is that as we make this easier for them to use, they do more and they actually see all these ancillary benefits around dev productivity or for data scientists. So I think that's what I would hope for 10 years out, is that it just, really obvious win-wins. And, for any security question, it always comes down to sort of cost and level of protection. And as you drive that cost down, it becomes obvious to choose the level of protection.
Abhishek, how about you?
As I answered this question, I'm compelled to go back to the founding principles of Samooha. This is something Kamakshi and I talked at length before starting the company. Our collective conviction is about how technology can and must further the extent of human capability. To that end, we believe privacy would not be a compromise or even an expensive choice, but a technologically protected consumer and business right, powered by a generation of innovative technologies like Samooha.
Thank you so much for joining. This was a lot of fun. Learned a lot along the way.
Thank you for having us.
Thanks for having us.
Thank you both.
The Analytics Engineering Podcast is sponsored by DBT Labs and is hosted by Tristan Handy and myself, Julia Schottenstein. Have comments, questions, or guest suggestions? Email us at podcast@dbtlabs.com. Our producers are Jeff Fox and David Krevitt. If you enjoy the show, please drop a review or share it with a friend. Thanks for listening.